Hello friends, welcome to my channel. So today we will be discussing a very amazing phenomenon and a question based on this phenomenon. In the first part of the video I will be discussing the phenomenon. In the second part I will be discussing the question based on the similar phenomenon. Okay, so the name of the phenomenon is sonoluminence effect. Have you ever wondered that can we convert sound energy into light energy? Yes, it is possible to convert sound energy into light energy using the uh, process called the sonoluminance SBL, SSBL or MSBL. Okay, sorry, sonoluminance effect or multi-bubble sonoluminance effect. Okay, the phenomenon is also known as sonoluminance effect or the multi-bubble sonoluminance effect. Okay, multi-bubble sonoluminance effect. So here in this effect we get to see that this process was discovered at the University of Cologne in 1934 as a result on the work on sonar. So it is a byproduct actually. We get to see what is a byproduct experiment. We get to see something new while we are going to do an experiment to achieve something else. Okay, so if we are doing an experiment E, suppose, to get something A, and in between process we get something B, okay, something new B, so this is also called a byproduct experiment, or the byproduct of this experiment is B. Okay, so similar type of situation here. As a work on sonar we get to know about a new effect. So what actually happened here? Here it is actually said that Hermann Frenzel and H whatever, I can't pronounce this word, put an ultrasound transducer, okay, transducer. Okay, what is a transducer? I will explain it. In a tank of photographic developer fluid. They hoped that this would speed up the process. Instead, they observed tiny dots on the film after developing and realized that the bubbles in the fluid were emitting light with the ultrasound turned on. So what is a transducer? Transducer is a device that converts signal of one form into signal of another form. So here it is converting the electrical signals into the sound signals. Okay, it is converting the electrical signals into the sound signals. And what is a developer fluid? Developer fluid is a type of fluid that converts the latent image into a stabilized clear image. Okay, so here what is the mechanism of the process? So the mechanism of the process is quite clear. First of all, we have a water or the fluid containing noble gas. Water, the fluid containing noble gas. So how is a bubble generated inside here? First I would like to discuss this, that how a bubble is generated. The bubble can be generated using several methods. Two methods I will be discussing here. First method is perturbing the water. Okay, perturbing the surface, the water surface, perturbing the water surface. And second method is to by this NICR heating, we can do the same thing. We can just generate a bubble by laser also. So first of all we generate the bubble, and then after we study all the other processes. So here we should have a noble gas, okay, water and noble gas solution. Here is the transducer. From here the noble gas is passed inside. This is the tank. Here is the heater that generates the bubble. This is a photoelectric, I just forgot to write here. This is a photo detector. Okay, photo detector means when the sound will reach the bubble, the all the mechanism will discuss it later, but when the bubble, the sound will reach the bubble, it will start emitting light, and that light will be detected by the photo detector. Now here is a microphone to check whether the sound is available in the tank or not. Okay, so here let us discuss the full mechanism. Okay, so what you will be amazed to know that the temperature inside the bubble is so high that it can melt steel. And what's the range of the temperature is actually 6000 to 12000 Kelvin. 6000 to 12000 Kelvin, or sorry, 20,000 Kelvin. This temperature is very high, and you will be seeing this in the upcoming part of the video, the problem. There also we get the temperature ranges, very high temperature ranges actually. So first let us discuss about the bubble dynamics. You can actually skip this part if you don't want to know about it, but if you want to know about the bubble dynamics, let us discuss, because this is the only vast mathematical part of the total situation. So here in this bubble dynamics portion, we get to discuss about the varying radii of the bubble or internal pressure of the bubble, the viscosity, surface tension, and other terms. So here we will be seeing many types of formulations and formulas that give us. So here are some approximation in all of these upcoming analysis. Killer mixes formulation or prosperity formulation or Rayleigh Rayleigh formulation, any formulation we get to know, we'll discuss it here. Okay, so here bubble will remain spherical, it will obey ideal gas law, the internal pressure remains uniform, and no evaporation or condensation takes place inside the bubble. Okay, so here we said that how we'll just see the how we'll just get this equation. It's actually a differential equation. What is this? This is actually a differential equation. Now let's see what is here in this differential equation. What terms we see? First you see Vs. Now here you see R dot R. Here we see another variable rho L. Now here we see PBRT. Now PA, P infinite. Now PBRT, rho L. Okay, now let us understand what is this. You don't have to do anything with this differential equation. I am just telling that what is this equation telling, what is this equation telling us about, or what is the Keller-Mixkis formulation of bubble dynamics. So here it is saying about the varying radii of the bubble, the internal pressure, and all the things, all the variables I have defined them here. So let us know what are these variables. R is the radius of the bubble, rho L is the density of the liquid in which the bubble has been generated, Vs is the speed of the sound in the liquid, in the medium actually. Now what is PBRT? Pressure on the surface of the bubble, therefore this suffix B. Now what is A? So A is the driving pressure or the delayed driving pressure, or the pressure due to the sound wave in that medium. Okay, so what happens here? Here the large radial oscillations of the bubble trapped in the sound field is written in the form of an equation. Okay, so from where this equation comes? They come from the Labuton's equation, a more expanded form of that. So here V sound field must be equal to the new sound field is equal to new bubble, and this at this time when the natural frequency matches with the bubble, here the time the large amplitude oscillations start taking place. Okay, so this is a differential equation telling that how radii varies with time and with other functions. All the functions have been written here. Now here what is the prosperity formulation? The prosperity formulation says that how it discuss about the internal pressure. Okay, what is this relate is the internal pressure of the gas. Here it is written as P dot. So P dot is 3 by R. What is R? R is the radial distance and capital R is the radii. Okay, now what is gamma? It is the Poisson's ratio or the adiabatic constant of the gas. Okay, adiabatic constant of the gas. Now here what is the Rayleigh placid formation? It is the most important of all. Okay, so here it gives us about the background static pressure, viscosity of the liquid, surface tension of the liquid gas interface, sinusoidal driving pressure of the gas. So once we understand about the Keller-Mixkis formulation, we can already know about the other two. So here it is the thermal conductivity of the gas, radial distance and radius. So it basically talks about the thermal conductivity, that talked about the radii, and here the Rayleigh placid equation talks nearly about everything. Okay, now what are these steps, or what are the steps in the mechanism that lead us to the main formulation? Okay, main formulation. So here the bubble is sustained. The bubble is sustained in a standing acoustic wave of moderate pressure. Okay, so pressure waves are generated and the bubble is sustained in that wave, that is it is stabilized according to that wave. Okay, once the bubble is stabilized in the antinode pressure of the standing wave, so whatever the pressure will be at the antinode of the standing wave, the bubble is just made equal to that and stabilized according to that. Okay, Now it is driven into highly non-linear oscillations. Okay, highly non-linear oscillations. See, this is a type of linear oscillation. Non-linear oscillation, I don't know any type of oscillation, but it's a periodic motion. Okay, it's a periodic motion. Now here, highly non-linear oscillation. So how it is, how this is done? So here it is done by like that. Pressure of the wave disrupts, once we increase the pressure of the wave, this will disrupt the steady linear growth of the bubble. So if the bubble is growing linearly, or the function, that is the radii function, is growing linearly, once we just increase the pressure of the wave, or the driving pressure, that is written as PA everywhere in the Killer-Miskis formulation, that function, if we just increase the value of that, it will disrupt the steady linear growth, or the linear function will change. Okay, now this causes the bubble to collapse in a runaway of reaction that only reverts due to high pressure inside the bubble at minimum radius of the bubble. Okay, so the bubble will collapse into a runaway of reactions. From here we get that this reaction, or what will happen, in it is discussed here. So what actually happens, let us see. So here it is said that the inertia of the collapsing bubble generates high pressure and temperature. So here we see the bubble, inside the bubble there is high pressure and temperature, and here if it is a present, if a gas is present or noble gas is present, the gas will ionize. Ionize means that if a gas can be written as G plus electron minus. Okay, so it will be ionized. Now this electron will interact with the neutral atoms, and this will result in a Bremsstrahlung radiation. Now what is the meaning of this word? It is a meaning that Bremsen means to break, and Strahlung means radiation. So breaking radiation or deceleration radiation, that means that suppose we have a positive charge, and here it is an electron. Okay, it is moving with some velocity, whatever it be. So here it will experience a net attractive electrostatic force, or it is moving under the potential, electrostatic potential. So its path will be curved, and we already know that the path will be hyperbolic path. We can just derive the equation of the path of the polar coordinate using Lagrangian mechanics, but here we just need that how much energy is released in such a process. That radiation or that energy is called the Bremsstrahlung radiation, or the breaking radiation or deceleration radiation that occurs due to other charged particles. So this type of energy that is emitted will be due to the free electrons and the neutral atoms, and this will seen in the form of light. So here we see how sound was converted into light. The actual mechanism of the process is still under construction, because most of the mechanism, this was the best mechanism that we can explain. There is also the quantum interpretation of the same thing, or the thermodynamic interpretation. So thanks for watching today's video. I hope you will like the today video, and in the next part of the video I will be discussing a numerical related to the same. Thanks.